What's going on, everyone? Welcome back to the channel. And in today's video, we're going to talk about the moderate level 4 out of 5 risk that has been issued on Monday and early Tuesday morning for the upper Midwest. So as you can see here on the screen, the three most populated areas is Minneapolis, Minnesota, La Crosse, Wisconsin, and Des Moines, Iowa. As we take a look at our probabilistic to break down as far as the amount of people that may be impacted, we can see that there is a lot of people within the population of these different areas, including almost, let's just say 13.6 million people, or close to 14 million people, with almost 7 million people within that moderate risk. So definitely something to be keeping an eye on. With that being said, let's go ahead and get into the models. So we can see here, starting off at 7 a.m. Central Standard Time, we have a positively tilted trough that's going to be over the western United States, and as the day progresses, that is going to move off to the east and to the northeast into the affected region. So with that being said, let's go ahead and put this into a loop and see how this develops over time. So as we could see, the trough is also deepening too, and there's also a couple little areas of shortwaves that you can see at 500 millibars. But we would also want to take a look at our 700 millibars, because that's going to be our bigger indicator. But you can see these little dip in our isobars that it could show areas as far as higher levels of vertical velocity and convergence into such as this region at 7 p.m. and to more of the northern Iowa and into the southern Minnesota region. But this is just only one factor, so we have to do the convergence of evidence to really figure out the whole picture of this. Now let's go ahead and continue to put this into a loop as more of the overnight and early hours progress, and we can see that the main areas that's going to be more focused around midnight and 1 a.m., kind of like over in those overnight areas. We can definitely see these more areas over here in Wisconsin, that there's a short wave, and that looks like more kind of on the eastern side of Wisconsin, or that's also on the enhanced risk. Looks to be like it could be possibly under the gun there. We do see a little areas of defluence of the loft that is going to increase our divergence. You have winds going here more of the north-northeast direction, and these other ones that are going a little bit more easterly. So you do see some areas of divergence that's going to increase the area of the vertical motion and vertical velocity for storm organization. Now let's go ahead and take a look at the 500 millibar vorticity. The vorticity is going to be about the amount of spin within the atmosphere. So of course, the more spin, if you have other ingredients such as the SLIM acronym, your shear, your lift, your instability, and your moisture, and you have enough, the vorticity, that's going to definitely show different areas. So let's start off here. We can see at 7 a.m. there's little areas of vorticity that looks like it's going to be going on, possibly some showers and storms, and more of kind of the border of Minnesota and also kind of in Wisconsin, which is kind of circling and make a little bit more depiction in there. As far as severe, it's it could be definitely on the cusp, but I think later on through the day it's going to be definitely more severe. But you can see little other areas starting to build in. So with that, we're going to go ahead and continue to put this into loop, see how this kind of develops once that trough is getting stronger. And we can definitely see a couple different other areas, more of northern Iowa and then into southern Minnesota. Isolated areas of vorticity, which is definitely going to show me that a higher risk for supercells compared to something that's on a line, or that would be more of a QLCS or quasi linear convective system. So as we keep going on and putting it into a loop, we can see there by, I believe, about the start of the peak time, about 7 p.m., probably about 7 p.m. to 10 p.m. is what I'm leaning towards right now for the peak of this activity, due to the current models available. But of course that can change, as we all know, within time. But we can definitely see there that there's a strong area that is going to be a nice line that's through western Wisconsin, Minnesota, and into Iowa. We go ahead and continue on. We can definitely see that we have plenty of vorticity to work with. Now let's go ahead and look at the jet stream. Here we're looking for two primary factors. We're looking for jet streaks, and we're also looking for areas of divergence. So as we could see here, go ahead and we could see that we have a nice strong jet. As you can see here, we want more of the yellows into the reds and the purples, right? So plenty of jet there to work with. So let's go ahead and put this into a loop and kind of see how it develops over time. So as we can see here, as we go developing time, it kind of weakens, but then it kind of strengthens a little bit, but that's later on in the day. But I also too, even though there still is a solid jet streak, right? So that's going to be over 80 knots. So it's definitely plentiful depending on the other levels of the atmosphere and with the speed and directional shear. But even with that, we can see little areas of divergence. So let's go back to kind of that 0Z here, about like when we're thinking things are going to be starting to go off here. So we could see that we have winds more kind of like the east-northeast direction there. And then over here, we have more of a northeast direction. So kind of all within this area right there. Looks to be possibly under the gun. But I believe kind of with the risk that it's going to be starting off more here on the kind of like the western Minnesota and then the Iowa. And we'll progress east over time. Now we're going to take a look at the 700 millibar chart, and here our primary factor we're looking for are shortwaves, which is going to act as another uplift mechanism in storm development. So as we can see here, starting off on that Monday morning, we can see that we definitely have a little bit of a shortwave that is going through parts of Nebraska and Kansas and then Oklahoma, and even some more subtle ones over here, which there could be as far as some shower and storm activity going on, and more of eastern Minnesota to western Wisconsin. So let's go ahead and put this into a loop, see how it progresses over time. So as we can see, let's get all the way to 0Z or 7 p.m. We can see a couple areas of our shortwave. Definitely a strong one that's more off of, I think that'd be kind of close to the Marquette region, which is also an enhanced risk, so definitely should be on the watch. Of course, we have some other areas here and over in Canada. But the main one as far as the United States are going to be a couple different areas. We could see here we have a little bit of a dipping here and more of kind of like western Iowa, and even in here in parts of Minnesota. So right there, it looks like kind of like this area right there would be the highest risk, in my opinion, for storm activity and also for severity. So let's go ahead and put this into a loop, see how it develops kind of in the overnight hours. And by the overnight hours, we could see that according here that the storms are going to be moving off more towards the easterly direction. It looks to be more of the Michigan region. But as far as the instability and everything is dropping off here, because this is going to be early morning, 7 a.m. Or actually, I think Michigan, I think you're actually on the eastern, if I'm not mistaken. So that'd be 8 a.m. your time. Looks to be that the severity of storms could lessen, but definitely something to keep an eye on. Now let's take a look at the vertical velocity. So here we are on the morning. We can see that there is a good amount of areas of vertical velocity, which is going to be signaling to me a chance of storm development that's already ongoing there in parts of Minnesota and also into Wisconsin. So let's go ahead and put this into a loop and see how this develops. The vertical velocity also too is going to be more of a visualization to the short waves we were just looking at, because it's going to be on the east side of that short wave that's going to enhance the vertical motion and uplift for storm organization. So as we go into a loop over time, we can see that there is more kind of that northwest Iowa starts to develop there at 1 p.m. their time. We continue on, we see a couple different areas, and by 0Z, you can definitely see about 0 to 3Z, so that's going to be from 7 to 10 p.m. Central Time, that in more northwest Iowa and then southern Minnesota, there's definitely a strong level of vertical velocity happening on. So there definitely could be a cab during the day that might be eroding around this time it's starting to fire. So it looks like intensification, and that's why I was thinking about kind of like in the 7 to 10 o'clock time. And even as we go on even a little bit later too, right? So this is going to be 1 a.m. time. I mean, it even looks like parts of Wisconsin and also kind of Minnesota, maybe parts of Iowa, given other metrics too. You can't have just vertical velocity, but it is a good indicator for as far as storms to be happening and developing. And then as we can see over the time, it kind of goes into eastern Wisconsin and more into Michigan. Next, let's go ahead and take a look at our lower level jet. So here we're looking for a couple different things. First, we'll start off with the jet. So we're looking for areas that are more about 30 knots or greater. Of course, there needs to be other metrics for tornadic development, but this is usually a good starter to show the potential for it. So as we can see here, starting off of the day at 7 a.m. Central Time, you can see that there's definitely a good area of that lower level jet going on. And then it's going to kind of weaken, but it's still above that threshold of 30. We still see plenty of yellows. And so we can even see all the way up until 0Z or 7 p.m. that there definitely is that strong area and more of North Iowa into southern Minnesota. And as it kind of progresses, we can see that Wisconsin, it really amplifies due to nighttime. So there's going to be less surface friction. And so the low level jet's going to be able to condense into a higher velocity jet. So that is going to definitely put them underneath the gun later on into more of the nighttime hours, into the overnight hours. And once again, they are in an enhanced risk too. So definitely something to be on the whereabout just because you're not in the main risk, but they definitely need to be weather aware. And as we go ahead and continue on a little bit further in time, all the way to 12Z or 7 a.m., we can see that that jet kind of dwindles off, but there definitely is a good sufficient amount of lower level jet, but it's not all be all. It's not, you have to have other ingredients. So with that being said, let's go ahead and continue on. An extra feature of our 850 millibar chart too is also going to be the winds that are going to show areas as far as our moisture. So as you can see, all these winds are coming out of the Gulf, and you can see a lot of that moisture that is condensed more into the Midwest and more parts of the upper Midwest. So that it's very strong moist layer all the way up to 850 millibars. Of course, in this area, it's not going to be exactly 1,000 millibars, be a little bit higher, but there still is that strong moist gradient that you usually want from all the way up to about 1 kilometer from the surface. As we can see, we put this into a loop as the hours continue on. There's definitely plenty of moisture to work with, especially in that western Wisconsin, southern Minnesota, and northern Iowa region. And of course, you get them later of the hours like we're talking about. Still plenty to work with for Wisconsin, so they definitely need to be on the lookout as the nighttime and even overnight hours progress. Next, let's go ahead and take a look at the surface. So here we're going to look for a couple different things. We're going to look for surface fronts, such as really lower area of pressure that's going to be there in South Dakota. We also see another one over here in Canada. Now let's go ahead and draw in our fronts. So we're going to draw some blue because these look like areas of the cold front. So we can see that there's going to be some kind of a front that's going to be extended from this front to here, which is probably going to be ongoing precipitation around this early morning time in more of the eastern Minnesota and western, kind of northwestern Wisconsin area, which shows that area of uplift. And we can also see it with the difference in the winds. You can see you got winds more out of the kind of the southeast direction, if this can draw on correctly. And then you have winds that are kind of going the opposite direction. So that wind shear that's definitely shown as a boundary. In addition, we're going to have another front that's going to be placed down here throughout the southern plains and kind of wrap out through here. And then the one other thing we need to look at is also our dew point map too, right? So this is going to help show us if there's any certain gradients such as dry lines, which we definitely see one. So we'll go ahead and draw that in too as well. So I'll go ahead and switch this color here, and then we will draw that in more of this orange color because that's just the way that they are there. So we can see as far as that is our synodic setup that is occurring at that particular time with plenty of moisture ahead of that boundary to work with. So let's go ahead and put into a loop as the day progresses, and we'll stop it there at 0Z. So now let's go ahead and draw all of our details in, starting off with our surface fronts. So let's start off with this first one that is going to be central over central Minnesota. There's also going to be a surface front over here in Canada. And then let's go ahead and draw on our fronts. So we can see we have wind shift, right? So we have more winds kind of more from the south, and here's kind of more from the southwest direction. So there's going to be a gradient throughout here for a front. And then our second gradient too, if looking at different things such as our gradient in our temperature, the wind shift direction, everything, we can see that there's going to be a surface front with this tongue as well that's going to be draped across there. And then of course, let's go ahead and look at the dew points, see if we see a dry line. We definitely do. So let's go ahead and switch that over, draw that in orange because that's our typical color. And we can see that that dry line is advancing even further east. That's going to help with the storm development a little bit past this time too, because if you remember later on into more of the early hours into the overnight, and even parts like Kansas City and everything like that is going to be more under the gun, which I think that's going to be as this dry line advances east, it's going to definitely help with that development. And at this time, 7 p.m., we can see that there is plenty of sufficient amount of moisture to work with. We can even see this triple point, different gradients where these two gradients come together. And also too, we can see our surface low. There's going to be a lot of enhance as far as kind of in this area for lower level convergence. You want areas of lower level convergence and more of the lower levels, and of course divergence in the upper levels. It causes air to spread more out, and you can get more air from below to go in, and increases chance for stronger supercells. So as we go ahead and put this into a loop and see how it kind of develops over time, we can see that over time even in more of eastern Wisconsin like we're talking about, has sufficient amount of moisture to work with for storms definitely persisting into the overnight hours, and even through and into Michigan as well. Next, we'll jump to our mixed layer cape and also our mixed layer sin. Right, so this is going to be our fuel, but of course if there's enough sin or you have a certain cap or a lid, you don't have any rising area. So as you can see, starting off, we just have like one little area over in Nebraska, that is going to have sufficient amount for possible storm development going on there, not necessarily severe. But as we can go throughout the day, we can see that there definitely looks to be some kind of a cap in place, but it erodes later on in the day. And then we can see a lot more areas, especially in more of southwest Minnesota and into northwest Iowa, to where that cap breaks there. And then it definitely gets to be right around that area at 10 p.m. and right around that moderate risk too, to where definitely need to be out on the lookout, kind of in that area. And of course, these storms are going to be moving just following the winds and more of an east-northeast, because this does show the storm motion too as well. Of course, it can deviate from there, maybe 10-15 degrees one or the other way, but it's a good general rule of thumb. So as we go ahead and put this into a loop and see the rest of the overnight, we can see, like we were talking about later in the overnight hours, more of that eastern part of Wisconsin needs to be under the outlook, and even parts of Michigan. Next, let's go ahead and take a look at the average total cloud cover. So here's going to be more of a visualization of that cap, or if you think like a pressure cooker, if you had a lid on, that steam's not going to rise, but it's going to create a lot of explosion once you take that lid off. So if the cap erupts, it's going to be an explosion environment for supercells to develop. So as we can see, starting off here at 7 a.m., we can see much parts of the upper Midwest. It's going to be more overcast, so it's going to limit destabilization of the atmosphere. But as we can see, as we progress throughout the more of the day, more of a northwest Iowa and a southwest Minnesota, the destabilization more occurs with more of those broken clouds, and even parts of southeast Minnesota too as well. And we can see that definitely going on into the later night hours, we can see that there definitely is a lot more areas of that happening. And so there definitely is going to be more of storms that we need to be on the lookout. I'd say maybe as early as, what is that? I want to say 4 p.m. Central Time is when things might start quote unquote popping off. And then it's going to progress east, northeast over time. So definitely you want to be, if you're more on the east side of that area, you definitely want to be on the lookout as this develops. Next, we'll go ahead and take a look at our precipitable water. So here we're usually looking for values that are going to be typically 1 or more, which is going to be more of our darker greens and into our blues, because you need a good amount of precipitable water for storm development. Doesn't necessarily mean severe. But as we can see, starting off 7 a.m., there's definitely a lot of moisture to work with, especially in the Minnesota and Wisconsin region. Kind of like we're talking, showers and storms could definitely be occurring there, possibly severe, possibly not. As we progress throughout the day, we can see that there's going to be more that's going to be affecting, and we can see that there's more going to be affecting into more of the southern Minnesota region, which if you look at the winds, you can see that a lot of the moisture is going to be falling from those winds, so it's going to help push the moisture into more of the upper Midwest. And then also too with that cap, and you can see as far as more of that destabilization happening, and then there we go about 0Z. So there looks to be a little new area over there, more western Nebraska throughout Kansas, and then that kind of progresses more north and east following those winds. And then we can see there at 10 o'clock too, there's definitely plenty to work with, and more of that moderate to enhance more of that eastern side region. And we go ahead and progress in the night, and there's definitely a lot of moisture to work with eastern Wisconsin needing to be on the outlook, and even into parts of Michigan. Finally, let's go ahead and jump to our bulk wind shear. So we're going to be looking from the surface to our 500 millibars, and we're looking for areas that are going to be 40 knots or greater. So we're looking for more of the reds, the purples, and the pinks. So as we can see here, 7 a.m. on Monday, we go ahead and go out through a time. We can definitely see that's going to be affecting off into more of the northeast direction, into the moderate risk area of western Wisconsin, and more of the southern Minnesota and northern portion of Iowa. And then as we can see, as we go on throughout more of the night into the overnight, it's going to be affecting off into more of that eastern Wisconsin region. So they definitely have ample bulk wind shear to work with. So for tornadic development too, and even supercells, so they definitely need to be on the lookout. So there definitely is ample bulk shear. There also is, as far as our instability that happens after that cap's eroding as well. And then as far as we have plenty of moisture to work with, and definitely some lift with that cold front, and also even too some short waves. So with that being said, I hope you enjoyed this video. If you did, make sure to give it a like and subscribe if you are not already to the channel. Thanks for watching, and until next time.